Alright, so here we have 4 different kinds of leaves. We have a smooth sumac that turns red. That's what Callan's cutting up first. And then we have a skunk bush that turns both kind of an orange and a yellow, which is this one right here. And then we have a hackberry, which obviously just turns this very pretty yellow color. And then we have elm, which also turns yellow. So we're going to do these 4 leaves on a leaf chromatography and see how they turn out. As you can see, we have all of our cups labeled, and we're going to cut them into tiny pieces first. That's our first objective. Alright, so after you cut them up into tiny pieces, if you have a mortar and pestle, that's what's going to be good. So what I've done is I've added 2 tablespoons of isopropyl alcohol, which is rubbing alcohol, and I'm basically just grinding the leaves. So what I just cut up were these yellow leaves right here, and I am just going to mush them and then let them set in the ethanol, and basically we're just trying to get the pigments into the liquid so that we can do our chromatography with them. Alright, so we have the, I guess you could call them solutions of our pigments made up. We have Siberian elm, smooth sumac, both green, and then also leaves that have turned completely red. And then we have hackberry and skunk bush. So what we're going to do is we're going to do a chromatography with each one of these and see how they're different. So in addition to the traditional method of doing leaf chromatography where you extract the pigments using isopropyl alcohol, I'm going to show you guys a different method that's actually very field friendly. So if you want to do this activity outside, this is the way that you should do it. So what you want to do first of all is draw a space on your filter paper that the pigment is going to go. And I usually like to go about a centimeter above the paper and then a centimeter up. So I mark 1 centimeter and then 2 centimeters with the pencil line. And then you always want to make sure that you write down what your organism is. So I am going to do a skunk bush, and that's this green leaf right over here. So this is what I'm going to be doing with my students in the field this week. But basically what you do is you take a leaf and you're going to break it up in your hands. You're going to roll it between your hands. You're going to roll it between your fingers. You want to really, really, really break it up. And this is going to take some time. So just take your time with it. Go slow. You're going to have to use more than 1 leaf. So you grab a couple leaves. And then the next thing you want to do is you want to scrape this on the pigment paper, on the filter paper, so that the pigments actually come off. And I'm using coffee filter paper, and it holds up really well to being scraped like this. So just FYI, it's going to work a lot better than, say, a paper towel. And as you can see, my leaf is starting to get really broken up. Scrape it long ways, scrape it up and down. You really want to get as much on there as you can. And then you're going to do this with all of your leaf colors, so your yellows, your reds, and anything that you have in between. So once you have your pigments on your filter paper, really you'll want to do at least a yellow, a red, and a green if you can. What you're going to do is you are going to put a tablespoon or 2 of isopropyl alcohol into your cup. So I'm going to do 1 because I'm going to hang my filter paper far enough for it to touch it. So what you want is you want this bottom area maybe about halfway up or so. Really it just has to be enough for the filter paper to touch the ethanol. And then you don't want your filter paper to fall in, and you don't necessarily want it touching the sides. So you can kind of droop it across like that. You can tape it, of course, to keep it up and out of the bottom. And then also, especially if you're outside, like I said, I'm going to be doing this activity outside with my students. I'm going to have them find sticks, and they're going to place sticks across the cup and let their filter paper hang. So you're going to put all of your filter papers into a cup or into separate cups. You don't want them touching. And then you're going to wait for maybe 30 minutes to an hour or so and see how the pigments separate over time. Alright, so my leaf chromatographs are finished, and as you can see, I've already documented it in my nature journal with the worksheet that you will download in Nature Matters Academy. And so up here, the green leaves I collected were from the Siberian elm. These are actually not Siberian elm. They are other ones that we tested as well. But the Siberian elm, I used all of those. So we have that one here. The yellow leaves were from the hackberry tree that I have here. And the red leaves were from the smooth sumac that I have here. So as you see, with the green pigment is going to be chlorophyll. That's your main player in photosynthesis, right? And chlorophyll can mask other pigments like yellow and orange. So the neat thing here is that these Siberian elm leaves that we used were completely green. They weren't starting to show yet. They weren't starting to change colors yet. And as you can see, those yellow pigments have always been there. And they'll actually, what will be left after the chlorophyll starts to break down or be reabsorbed by the tree. And so that's kind of neat that you can see that. The hackberry leaves were pretty much completely yellow, and so really there wasn't a lot to show here. You can see there's just a tiny bit of green down here at the bottom, but for the most part the main pigment is yellow. And then this is really interesting to see because I did two different types of smooth sumac leaves. I did one that was, here we go, red leaves. So that's these guys right here. They're completely red for the most part. And then the other ones were turning red, so they were about half green and half red. And as you can see, the ones that were green and red, you can see a lot more green pigment and the red pigment above there. And you can even see a little bit of yellow pigment, which is interesting. And then on the ones that are mostly red, you see a little bit of green pigment, but you can definitely see that the majority is red. So let's see. So the red pigments are called anthocyanins. The yellow pigments are called xanthophylls. If we had more of an orange pigment, those are called carotenoids. Then obviously the green pigment is called chlorophyll. And so what happens is that these different pigments have a different molecular size. And as you can see, green stays here at the bottom, so its molecular size is larger, and it's harder for it to travel up the paper with the other pigments. The other pigments like yellow and red are smaller and they travel further up. So that's how you get to see this separation when you do the chromatographs. So one last thing I want to mention about the pigments is that first of all, the yellow and orange pigments are also responsible for photosynthesis to some extent, just not as much as green. And I need to look up to what extent the red pigment plays in these leaves. But the interesting thing is that the red doesn't show up until the fall. So the shorter days and the cooler weather actually triggers the red pigment to be produced. Whereas we know that the yellow and the orange are always present in the leaves. So if I did a leaf chromatograph on a smooth sumac in the summer, I would just get green. I wouldn't have these red pigments because they haven't been produced yet. And as these, one of the reasons that you see these yellow pigments showing up in the fall is because they take longer to break down than chlorophyll does. So kind of the process is chlorophyll begins to break down. I think some of it's reabsorbed a little bit by the plant, and then what's left are these pigments, and they take a lot longer to break down, and then obviously eventually they do, and the leaves turn brown. But that's kind of the process with these pigments and leaf chromatography. I hope you enjoyed this video. And as I said before, I really like the field method that I use for doing this, where I just scrape the leaves onto the paper. I feel like it saves a lot of time, and it's something that you can actually do outside and not have to come in the house and use a mortar and pestle and all that. But the mortar and pestle is good in its own right because you're teaching scientific protocols, right? Just like following a recipe. If you don't follow the recipe, you're going to get something different than probably what you desire. It could be better, who knows, but it could be a lot worse. And so it's important for kids to learn how to follow procedures step by step to get a desired result. And as we know in the sciences, you can follow something step by step and still not get your desired result, but that's also part of the scientific process, right? Is learning that you have to do things multiple times and make really small changes and whatnot. So anyway, I hope you guys enjoyed this video. If you have any questions, leave them in the comments. All right, thanks.